Hi, my name is Kylie Bichard, and my current event is Oman's mountains may hold clues for reversing climate change. So, the event. Geologists believe that they may have found an efficient way to remove carbon dioxide from the air and oceans, hidden in the Oman Mountains. The Oman Mountains contain one of the world's only exposed sections of the Earth's mantle. Geologists are taking core samples from this section in hopes of understanding how a spontaneous natural process from millions of years ago transformed carbon dioxide into limestone and marble. These geologists are testing ways on how to remove or recycle carbon that is already found in the oceans and atmospheres. Peter Kellerman, geologist from Columbia University, has been exploring Oman hills for nearly 3 decades in hopes of understanding this natural phenomenon. Every single magnesium atom in these rocks has made friends with the carbon dioxide to form solid limestone, magnesium carbonate, and quartz, says Kellerman. Kellerman and a team of 40 scientists have formed the Oman Drilling Project in order to better understand this process, in hopes of being able to replicate it. They hope to answer the question of how the rocks managed to capture so much carbon over the course of 90 million years, and to see if there's a way to speed up that timetable. Almost half of the Oman landscape contains peridotite, a rock that naturally removes carbon dioxide from the air and petrifies it into rock. As of now, this mountain contains about 1 billion tons of carbon dioxide that was taken from the atmosphere and the ocean. Ever since the signing of the Paris Agreement, Kellerman and his team have been working urgently by extracting dozens of core samples, in which they hope to construct a geological history of this process that turns carbon dioxide into different carbonate forms. Kellerman believes a drilling operation could cycle carbon-rich water into the newly formed seabeds on oceanic ridges, far below the surface. He believes the submerged rocks will chemically absorb the carbon, just as Oman's mountains did. If this is true, then the water could cycle back to the surface to absorb more carbon from the atmosphere, similar to a conveyor belt. This project could take years of more testing, but Kellerman has high hopes. A similar project was also done in Iceland, where a geothermal plant has been utilizing the practice of carbon sequestration by injecting carbon dioxide into volcanic bedrock, which permanently stores this greenhouse gas by turning it into minerals. Although this project is somewhat effective, it still needs more testing, just like the Oman Drilling Project does, and has been criticized for requiring massive amounts of water. So what does this mean for society? Well, if humans can learn how to make these reactions work fast, safely, and at industrial scale, then our civilization has a real chance to recapture the excess carbon dioxide in the atmosphere and limit the total warming, says Stuart Hasseldine, a professor of carbon capture. The major problem with this project is the use of water, as well as the reliance of the energy industry in funding. This could limit how far the project gets. Kellerman hopes the energy industry, with its skill of offshore drilling, will help take up the project. However, the energy industry already makes lots of money, and there is a high chance they may reject this project. As of now, this $3.5 million project is funded majorly by NASA. So if we want to avoid being victims of the 6th grade extinction, we better look at all the ways we can recapture hundreds of billions of tons of carbon dioxide and be well on the way to finishing that recapture by 2050, Stuart Hasseldine says. This project could in general begin the reversal of climate change impacts, which could help avoid catastrophes such as severe storms, flooding, drought, and mental illnesses, which can be caused by climate change.